This is Precalculus, section 6.3, day 2. We're discussing trigonometric functions of angles. So in chapter 5, we learned the reciprocal identities and Pythagorean identities with respect to t. These identities also hold true for theta. So sine of theta we know is the reciprocal of cosecant. So sine of theta is equivalent to 1 over cosecant of theta. And similarly, cosecant of theta is equal to 1 over sine of theta. Cosine of theta is the reciprocal to secant, so cosine of theta is equal to 1 over secant of theta, and similarly secant of theta is equal to 1 over cosine of theta. Tangent is the reciprocal to cotangent, so it's equal to 1 over cotangent of theta, and cotangent of theta is equal to 1 over tangent of theta. Nothing new, we're just switching the t and the theta. Tangent of theta is also equal to sine of theta divided by cosine of theta. Since cotangent is the reciprocal of that, cotangent is equal to cosine of theta divided by sine of theta. Pythagorean identities we learned were derived from the Pythagorean theorem. And since cosine squared corresponds to y, and since cosine squared corresponds to x squared, and sine squared corresponds to y squared, and we already know that x squared plus y squared equals 1. We can just replace x with cosine. So we have cosine squared of theta, and replacing sine with y plus sine squared of theta equals 1. Dividing each term, the cosine, the sine, and the 1 by cosine squared gives us 1 plus tangent squared theta equals secant squared of theta. And then from the original, cosine squared theta plus sine squared theta plus equals 1, dividing each term by sine squared of theta gives us cotangent squared of theta plus 1 equals cosecant squared of theta. Example 1, it tells us to express cosine of theta in terms of sine of theta, where theta is in quadrant 3. The knowledge that cosine and sine, or that theta is in quadrant 3, tells us that sine and cosine are both negative. So first, to express cosine of theta in terms of sine, we want to start with the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. And we're just going to solve for cosine. So subtracting sine squared on both sides gives us cosine squared of theta equals 1 minus sine squared of theta. Taking the square root of both sides, we're left with cosine of theta equals the square root of 1 minus sine squared of theta. And anytime we take the square root, we know that we have plus or minus. And since we know that theta is in quadrant 3, we know that cosine of theta is equal to the negative square root of 1 minus sine squared of theta. So this is how you would express cosine of theta in terms of sine. For our second example, it says if sine of theta equals 2/3 and theta is in quadrant 2, we're going to find cotangent of theta. So we're given that theta is in quadrant 2. This tells us that cotangent is negative in quadrant 2. And we know that sine of theta equals 2/3. So cosecant of theta equals 3 over 2. Just by understanding those, that sine of theta is just the reciprocal of cosecant of theta. This time we're going to start with cotangent squared of theta plus 1 equals cosecant squared of theta. Because we're trying to find cotangent, so we want to start with something that has cotangent in it. So then just solving for cotangent of theta, we have to first subtract 1. So cotangent squared of theta equals cosecant squared of theta minus 1. And then taking the square root, cotangent of theta equals the square root of cosecant squared of theta minus 1. And again, anytime you take the square root, you're left with two answers, positive and negative. Since we know that cotangent is negative in quadrant 2, we're going to have cotangent of theta equals negative square root of cosecant squared of theta minus 1. Now to solve for cotangent of theta, because it asks us to find cotangent of theta, cotangent of theta equals the negative square root. Since we first determined that cosecant of theta equals 3 over 2, we are just going to substitute this 3 over 2 in for our cosecant of theta. So cotangent of theta equals the negative square root of 3 over 2 in parentheses raised to the second power minus 1. Simplifying, we are left with 9/4 minus 4/4 underneath the square root, which is the negative square root of 5 over 4, which, simplifying this further, gives us the negative square root of 5 divided by 2. So negative square root of 5 divided by 2 is what cotangent of theta equals. Our third example asks us to find the values of the trigonometric functions of theta from the information given. If we are given that sine of theta equals 3 over 3/5 and it's in quadrant 2, we could either do what we first did, or we could create a right triangle. So if we know that our triangle is in quadrant 2, or if our theta is in quadrant 2, and since sine is opposite over hypotenuse, we know that our opposite leg is 3 and our hypotenuse is 5. To find our missing leg length, we can either understand what the Pythagorean triple is, or we can use the Pythagorean theorem. We do so just by taking x squared plus 3 squared equals 5 squared. So x squared equals 25 minus 9. X squared equals 16, so x equals square root of 16, which is 4. And since we're in quadrant 2, we know we have to move left 4 to get up to our terminal point. So the 4 is negative. So now, to find the rest of our trig functions, cosine we know is adjacent over hypotenuse, so negative 4 over 5. Secant is just the reciprocal of cosine, so it's negative 5 over 4. And it doesn't matter whether the negative is on top or bottom, still multiplying by negative 1. Tangent of theta is opposite over adjacent, so negative 3 over 4. And cotangent is just a reciprocal of that, so negative 4/3. And then cosecant is just the reciprocal of sine. Since we're given sine is 3/5, cosecant of theta is just 5/3. The other option we could have used to solve this problem is to use the fact that sine squared of theta plus cosine squared of theta equals 1 in order to find cosine. Next, we're going to learn how to find the area of a triangle when we're given two sides, A and B. We must be given A and B and then also an angle theta. Find the area of triangle WTH, this entire triangle. We know the area formula for a triangle is just 1/2 times base times height, which is just equal to, since our base is the longer length on the bottom, we know our base is equal to A, and our height is just labeled H. So 1/2 times A times H However, we don't always know our h, so using our theta, we can determine what h is. Sine of theta is equal to h over b. So then solving for h equals b times sine of theta. So then just substituting in b times sine of theta for h in our area equation, we are left with 1/2 ab times sine of theta. It's important to know that a equals 1/2 ab sine of theta is the area of any triangle with side lengths a and b and the included angle. Theta. It's important to know that it's included because we're going to see some examples where we are given in a theta that's an exterior angle, and we need to first find that interior angle. So for our final example, example 4, it says find the area of the triangle. We're given all 3 side lengths and also a theta. So we need to draw in a height, which is h. So using that interior angle, 35, we're going to have to use side lengths 13 and 24. So the 3 things we're going to be using in this equation are the 13, 35 degrees, and 24. We know our formula is a equals 1/2 times a times b times sine of theta. So just substituting in our information, a equals 1/2 times 13 times 24 times sine of 35 degrees. So making sure your calculator is in 35 degrees, or it's in degree mode. And then just putting this information into your calculator just gives you a equals 89.48. It's important to use units, so we're going to say units squared. Squared since we're discussing area. So any triangle can be, or you can find the area of any triangle when given 2 side lengths and the interior angle. So it's just important to first look at your picture and determine what side lengths you're going to be using and what angle you'll be using to use in your equation.